This video is about demonstrating the knowledge of triangle inequality and understanding the relationship between sides and angles of a triangle. So in our angle and side relationships, the biggest side is always going to be across from the biggest angle, and the smaller side is always going to be across from the smaller angle. So when you are doing these types of problems, you're going to be given one set of information, either the angles or the sides, and then you have to place the other in order. So in number one, we want to order the segments from shortest to longest. So using our angle measurements, we're going to look at the smallest angle. So 49 is the smallest angle. So across from 49 is going to be the smallest side. So it's going to be RD. Our middle angle is going to be 63. So across from that side is the middle side, which is going to be RE. And then our largest angle is going to be across from the longest side. So our longest side is going to be ED. In number two, you are given two angles of the triangle. So in order to put them in order, we need to know the third angle first. So to find that angle, we're going to subtract from 180. So 180 minus 96 minus 51 gets us 33 degrees. So 33 is the smallest angle. So the shortest side is going to be SE. The middle angle is angle E. So that side is going to be SA. And then the largest angle is across from the longest side, which is going to be EA. In number three, we have three angles, except for that they have variables with them. So first, we need to solve for x. So in order to do that, we know all three angles in a triangle have to equal 180 degrees. So we have x squared plus 4x plus 5 plus 98 is equal to 180. So we get x squared plus 4x plus 103 is equal to 180. X squared plus 4x minus 77 equals 0. So we need two numbers that multiply to negative 77 and add to 4. So those numbers are going to be x plus 11 and x minus 7. When we switch our signs, x is going to be negative 7, or negative 11 and 7. Now, in this case, we're not going to use negative 11 because that would make this angle negative. So when I plug in 7, I get angles of 49 degrees because 7 squared. And then I have 4 times 7 plus 5, which is 33 degrees. Now that I know all three of my angle measures, I can place my segments in order. So 33 is the smallest angle. So our smallest side is CB. Our next angle is 49. So our next side is going to be CU. And then our largest angle is C, which is across from the side BU. Now, with these two letters of our segments, it's okay if you switch the order, as long as we are still talking about the same segment. So BU and UB are going to be the same. Now let's switch and do angles from smallest to largest. So the same principle applies here. The smallest side is across from the smallest angle. So 8 is our smallest side, which means angle H is going to be our smallest angle. 15 is our next side. So our next angle is going to be angle T. And our largest side is 17, which makes angle A the largest angle. In number 5, our smallest side is 6.1. So that's going to be angle Y. Then our next side is 6.3. So that is going to be angle R. And our last side is 7.4, which means the largest angle is angle C. Now in number 6, we don't know our angle measurements. We do know the perimeter. So sides do not equal a specific number, they equal the perimeter. But the perimeter can range from any type of number. It can be small or it can be really big. So we're going to add up our three sides and set equal to the perimeter to find our side length. So 4x plus 5 plus 15 plus 2x plus 3x plus 2 is equal to 49. So when we combine like terms here, we have 9x plus 22 is equal to 49. we can subtract 22, so 9x equals 27. We divide x is 3. Once we know x is 3, we can substitute in. So 3 times 3 plus 2 is 11. 15 plus 2 times 3 is 21. And 4 times 3 plus 5 is 17. So when we go to place our sides in order, our smallest side is 11, which is across from angle F. Then we have the side that's 17, and that's across from angle L. And then we have our largest side of 21, which is across from angle Y. So in triangle inequality, the sum of the two smaller sides must be greater than the third side length. So we want to figure out if these are a triangle or not. So what we're going to do is we're going to take the two smaller sides and add them together. So in this case, 5 plus 8. And we're going to see what their relationship is to 12. So 5 plus 8 is 13, which is greater than 12. So yes, this is a triangle. In number 10, we have 12 plus 13, and we're comparing that to 26. 25 is less than 26, which is not what we want. Remember, it must be greater than. So this is going to be no, not a triangle. In number 11, we have 5 plus 10. We're comparing that to 15. 15 is equal to 15, which is also not the relationship we're looking for. So that is also not going to be a triangle. So in number 10, we want to write an inequality that describes the possible lengths of the third side of the triangle with two lengths of 12 and 15. So our third side here is going to be x. So we're going to do three inequalities rotating which one's going to be the biggest. So we have 12 plus 15 has to be greater than x. 12 plus x has to be greater than 15. And 15 plus x has to be greater than 12. So in the first inequality, we can just add those together. 27 is greater than x. If we switch this around, that means x is less than 27. In the second inequality, when we subtract 12, we get x is greater than 3. And in the third inequality, we don't even need this inequality because x plus 15 is already greater than 12 because 15 is bigger than 12. So we don't need to look at that inequality. So what we see then is x is greater than 3 but less than 27. So how we're going to write that is we're going to put x in the middle of those two numbers. Your smallest number is by subtracting the sides, and your bigger number is by adding the sides. So in number 11, two sides of a triangle are 19 and 7. What is the possible length of x? So instead of doing all three inequalities, we can just put x in the middle. To get our first number, we're going to subtract. To get our second number, we're going to add. So it has to be between 12 and 26. Number 13, can the sides of a triangle have 10, 19, and 8? Use complete sentences to explain. Well, the larger number is 19, so we want to see, is 10 plus 8 going to be greater than 19? Well, 18 is less than 19, so is this a triangle? No, because the sum of the two smaller sides is not greater than the third side. In number 13, use the distance formula to find the side length. So remember that distance formula is going to be x2 minus x1 squared plus y2 minus y1 squared. So we're going to do three different sides. We need to do dr is going to be our first side. So in dr, the x coordinates are 6 and 6. So 6 minus 6 squared plus 4 minus negative 2 squared is going to get us 0 squared plus 6 squared, which gets us 36. And the square root of 36 is 6. So dr has a length of 6. Then we're going to try our next side. We're going to try ry. We want to figure out the distance of ry. So we have 4 minus 6 squared plus 4 minus 4 squared. That gets us a square root of negative 2 squared plus 0 squared, which gets us a square root of 4. The square root of 4 is 2. So ry has a length of 2. And then the last side is going to be dy. So we have 4 minus 6 squared plus 4 minus negative 2 squared. So that's going to get us negative 2 squared plus 6 squared, which is going to get us 4 plus 36, which is the square root of 40. So if we get our decimal here, the square root of 40 is going to be 6.32 for our length of dy. Once we have our side lengths, we want to classify our triangle by side lengths. So by side lengths, they're all different sides, so that means this triangle is going to be scalene. If we draw our triangle DRY, RY is 2, DY is 6.23, DR is 6. We want to put the angles in order from smallest to largest. So our smallest angle is going to be D, which is across from 2, then angle Y, which is across from 6, and finally angle R, which is across from 6.32.